Good morning, everyone. I hope you guys had a great day and a nice weekend and we're ready to start a new lesson. So today we're going to start with lesson 5.3, which is solving polynomial equations. So for today's lesson, we're going to first start looking at some polynomial factoring techniques. And so for this lesson, you're going to need some paper, a pencil, a calculator, and you can always go to www.calculator.net if you do not have a calculator with you. And this gives you a free online, or even you can use your cell phone and log into there, and you can produce this calculator right there on your phone. You will need your textbook on page 297, and you'll need to have access to your RenWeb. You need to have your own personal login information in order for you to be able to download homework 54 and to be able to submit this assignment to the homework drop. If you do not have that, please make sure you contact the office, and they will give you the information that you need in order to create your own login. And I also believe that an email was sent out to your parents with a video on instructions how to download the homework as well as submit it to the drop and be able to create your login information. But if you have any questions, please message me through Remind, and I'll be more than glad to help you out. All right, so we're going to go ahead and get started. So the first thing that we're going to talk about today, again, like I told you, were the factoring polynomial techniques. We're going to write this down. Polynomial factoring techniques. So polynomial factoring techniques. All right, so go ahead and write that down. So when we find our first method, we're going to do method 1. I'm going to write this down. Method 1. So method 1 is factoring out the GCF. And what this means is they want us to factor out the greatest, and that's what our G comes from, common, that's where your C comes from, factor, and that's where your F comes from, of all, and I'm going to underline this, all the terms in the polynomial. All right, I underline the all multiple times because sometimes in a polynomial you might have 2 terms, you might have 5 terms, you might even have 7 terms. So however many terms we happen to have is where we're going to pull this greatest common factor from all of them, not just 1 or 2 of the terms. All right, so we're going to use our first example today. It is going to be 15 x to the 4th minus 20 x to the 3rd plus 35x squared. So what we have to first of all do is look at trying to find the greatest common factor of the coefficients. To do this, we must first be able to determine who are our coefficients. So our coefficients are the values right here in front of our variable. So our first coefficient is 15. So write that down, 15. Our second coefficient is negative 20. Yes, we use the sign to the left of the coefficient to determine whether it is positive or negative. And our last coefficient is 35. And it's a positive 35. We do not need to write plus 35. It's just understood. From here, we're going to look for our greatest common factor. So to find that greatest common factor, we're looking for the largest factor of each of these individual values and see which factor would divide into 15 and into 20 and into 35. So Jessica, what do you think the greatest common factor would be? That's right, Jessica, it is 5. So in case you have forgotten, or maybe you're not real sure, or you don't remember, I'm going to show you how to find that greatest common factor in case you get lost. All right, so if you have bigger numbers, I'll move this up into the screen a little bit. we're going to take our first factor of 15. In order to get 15, we can multiply 1 times 15, or we could multiply 3 times 5. For negative 20, we'll leave the negative alone for a second and just look at factors of 20. We can multiply 1 times 20, we can multiply 2 times 10, or we can multiply 4 times 5. For 35, we can multiply 1 times 35, or we can multiply 5 times 7. So we're going to disregard the ones, because if we divide by 1, we're right back where we started with the original number. So 1 is never going to help us out, and it will not be a greatest common factor. So now then we're going to look at the other remaining numbers. So we notice the first factor we have here is 15, but 20 and 35 do not have 15 as a factor. Then we look at the 3. 20 and 35 do not have 3 as a factor. Then we look at 5, and we notice that 15 has a factor of 5, 20 has a factor of 5, and 35 also has a factor of 5. There are no more factors in 15 to compare, which means if there's no more factors for 15 to check, then there cannot be any other greatest common factors, because all 3 would have to share the factor. If you would have had more than one factor that they shared, you'd pick the largest number of the numbers that they share. That makes the greatest common factor. So we're looking for the greatest number or the greatest factor they share. All right, so now we're going to move on, and we need to find next the GCF, or the greatest common factor of the variables. In order for it to have a greatest common factor for variables, all 3 terms, or all 3 factors, or all factors in the polynomial must contain the same exact variable, even though that variable is to a different power. So let's look at ours. This first term contains an x, the second term contains an x, and the third term contains an x. So since all terms in our polynomial contain the variable x, we can have a greatest common factor with x. But now we must look at those exponents. This exponent is to the 4th power, this is to the 3rd, and this is to the 2nd. We want to pick the exponent with the lowest value. So of the 3 numbers, 4, 3, and 2, 2 is the lowest of the 3 values. This means that our greatest common factor of x to the 4th, x to the 3rd, and x to the 2nd, our GCF of this would be x to the 2nd, because x to the 2nd is the lowest exponent of the 3. We pick the lowest because remember, when we divide with exponents, we subtract, and we want to get a positive value when we subtract. So 4 minus 2 would be a positive 2, and 3 minus 2 would be a positive 1, and 2 minus 2 would be a 0. If you chose any of the other factors, you would get negative values, and we don't want negative values when we finish dividing or subtracting the exponents with our variables. So I move the screen up a little bit. So now that we have found the GCF of our coefficient, we have found the GCF of our variables, we now want to find the GCF of the polynomial. And this is very simple, because the GCF of the polynomial is just putting together the GCF of the coefficient, which is 5, with the GCF of the variables, which is x squared. So now that is the greatest common factor. So from here, we're going to take each of our term in our original polynomial, 15x to the 4th, minus 20x to the 3rd, plus 35x squared. And we are going to divide each term in the polynomial by our greatest common factor of the polynomial, which is 5x squared. All right, so now we're going to go ahead and simplify. All right, so 5 divided by 5 we know is 1. 15 divided by 5 is 3. And each of these top numbers must be divisible by the number that we choose for our GCF of the polynomial, otherwise we pick the wrong GCF. X to the 2nd divided by x to the 2nd is x to the 0, which is equal to 1. And 1 times 1 is 1. x to the fourth divided by x to the second is x to the second. So now we got 3 times x to the second on the top. The middle term, we got 5 divided by 5, which is 1. Negative 20 divided by 5 is a negative 4. X to the second divided by x to the second is x to the 0, which is equal to 1. So now times 1, which is 1. And then x to the third divided by x to the second is the same as x to the 3 minus 2, which is x to the first, or just x. So now we have negative 4 times x in the middle term. The last term, we do 5 divided by 5, which is 1. 35 divided by 5, which is 7. X squared divided by x squared is x to the 0, which is 1. And 1 times 1 is 1. X to the second divided by x to the second is x to the 0, which is 1. So now we have 7 times 1. So now we can have our final answer. So our first factor, we got 3 times x squared, which makes 3x squared. We have negative 4 times x, which is negative 4x. And we have 7 times 1, which is a positive 7. So now this would be the factored out of after we take out our factor out our greatest common factor. This is what we're left. So now we have to write our answers, our two factors, just like our previous lesson. We cannot take our greatest common factor here and throw him out with the bathwater. He is still a part of our answer. So we have to show that we divided by 5x squared, and then we ended up with 3x squared minus 4x plus 7. We will now take this value and equal it to 0. From here, we are going to want to find the zeros of each of these individual factors of the 5x squared and of the 3x squared minus 4x plus 7. So we'll go ahead and change the paper out and show you how to do that. So again, if you need to, pause the video. All right, so I'm going to write out factored form. We're going to take our first factor, which is 5x squared. We're going to set it equal to 0. Then we're going to take our second factor, which is 3x squared minus 4x plus 7, and we're going to also equal this one to 0 as well. All right, so for here, what we need to do is start with the very first one, and we're going to try to get this x by itself. So the first thing we must do in order to get just plain x, we first need to isolate the x squared. So we have a 5 times x squared. Well, the opposite of multiplying is, that's right, Trey, it's dividing. So we're going to divide on each side by the coefficient, which is 5. So we divide on this left side. 5 divided by 5 is 1. And 5 divided by 5 is 1. So now we're left with 1 times x squared on the top, which is x squared, all over 1, which is just x squared. And then 0 divided by 5 is 0. So now we have an x squared, but we want to get down to an x. So we have to do the opposite of squaring, which is what? That is right, Alex. It is square root. So we need to find the square root of x squared, and we need to find the square root of 0. So the square root of x squared is x, and the square root of 0 is 0. Now notice we don't have any plus minus here, because 0 does not have any sign. So it doesn't have a positive value or a negative value. 0 is just, well, 0. All right, so now we're going to move on to the next one. Here, we just cannot solve for x like we did here because we have an x squared and an x. So to solve this, we have one of two ways. Method 1 would be to do our Xbox method, which we have learned. If the Xbox method does not work, you must use the quadratic formula to find your zeros. When the Xbox method doesn't work and you are resorting to the quadratic formula method, you will have answers that will have radical signs. Will be square root of something. They might even be imaginary, containing those i's that we've talked about earlier. So we're going to go ahead and set up this X box for you guys to look at and make sure you guys understand and remember some of the stuff about the X box. So we're going to go ahead and draw our X box. Remember, on our X box, the top value is our A times C value. Down below is our B value. On the left side are the wings of them. We have the factors of A times C. Then we divide these factors by the A value. So in order to get started for our X box, remember the first thing we must know are A, B, C's, quadratics, and me. Alright, so now let's go ahead and identify those A, B, C's. Alright, so Lainey, what are our A, B, C's? So who is in the A spot? That's right, Lainey. Our A value is 3. There it is. That is our A value. What is our B value, Lainey? That is right, -4. Remember we said that the sign to the left indicates the sign of our coefficient. All right, Lainey, and what's that last one? That's correct, Lainey. It is a +7. That's our C value. So now we know our A, B, C's, quadratics, and me. All right, so now we're going to go ahead and do our own little X box. So here we go. All right, so A times C would be 3 times 7, which is 20. Now we're going to do our B value. What is our B value? That's right, Jeremiah Burton. It is -4. So we're going to write that down. So to find put that 21 over here. Here's our that's our A times C. I'm a little note. A times C. I'm looking for values that I multiply to get 21. That when I add them, they make this -4. So our first factors we could try would be +1 times +21. Is 1 plus 21 ever going to be -4? No. Well, let's try if we made it in 21 to add those together. Would that make a -4? No. What if we did a +1 and a plus a -21? That make a -4? Nope, that wouldn't work either. So now we got to think of, what else could I multiply together to get 21? Oh, that's a good job, Jessica. She said I multiplied 3 times 7 to get 21 up here. So 3 times 7 must be 21 as well. So let's try that. If we do 3 plus 7, does that make a -4? Nope. How about if we do a -3 plus 7? Does that make a -4? Nope. What if we do a -3, not a -3, but a +3 plus a -7? So +3 plus -7, yes, that makes a -4. So we want to use those factors, +3 and -7. Let's see. But will that give me a +21 when I multiply them together? No. +3 times -7 is a -21. Man, that's not working for us. So what this tells me is that I cannot use my X box method. I am going to have to use the quadratic formula. So we're going to make a note here. X box method doesn't work. We're making ourselves a little note. We cannot use the X box method on this particular problem. And you can see how we came up with that. All right, so now we're going to move this guy down and say we've got to use that quadratic formula. So let's go ahead and make sure we know the quadratic equation. So quadratic equation. Our quadratic equation is x is equal to -b plus or minus the square root of b squared minus 4ac all over 2 times the a value. So here's our quadratic equation. Now we're still going to use the values of a, b, c that Lainey helped us out here with. We know a is 3, b is -4, and c is 7. This is important. You don't try to throw this all into your calculator at one big time, otherwise you're going to get the wrong answer. Because remember I told you that if we're using this quadratic equation, because our X box method is not working, then we're going to have radicals. That means we're going to still have a square root of something in our answer and potentially have some I values in there for imaginary numbers. So we're going to go ahead and start this process off by substituting our values in for x. So x will equal negative, and we're always going to put in parentheses the value that we're substituting in so we do not mess up our signs. That's very, very, very important. So our b value is negative 4. So I'm going to put negative 4 in here. Plus or minus the square root. All right, here we go. Lots of room. So I'm going to take my b value as being squared. So my b value is negative 4. So I'm going to put my negative 4 in here. Then it says minus 4 times my a value, which is 3, times my c value, which is 7. I will now put this all over 2 times my a value, which is 3. Fantastic. All right, so I'm going to move this up a little bit so you guys can see in the screen. And we're going to make some adjustments over here to the right. All right, so here we go. I want to make another color so we can kind of keep this together. This is the reason why I wanted to make sure you put your negatives or any value that you substitute into parentheses so we don't mess up our signs. So we get a negative. It's like a negative 1 you don't see using distributive property. Negative 1 times negative 4, positive 4. Then we have our plus or minus. And again, we're not going to completely simplify. We just want to do one part at a time. So we got a negative 4 squared. This means negative 4 times negative 4. And remember, a negative times a negative is that's right, Christian, a positive. And 4 times 4 is what, Christian? That's right, 16. So negative 4 squared is equal to a positive 16. So now we have to multiply these three values. Negative 4 times 3 times 7. So we're going to do negative 4 times 3, which is a negative, that's right, Jessica, 12. Then we're going to do that negative 12 times 7. That's right, Jessica. We get a negative, so we write minus 84. And we're going to put this all over 2 times 3, which is 6. All right, so now we're going to move down below here, and we're going to simplify this version underneath the radical sign. So we got our x is equaling still. We got 4 plus or minus the square root of. So now let's solve 16 minus 84. That's right, Jeremiah Pauling. You get negative 68. All right, so now here we have our negative 68, and we're going to put this all over 6. Now remember, we learned back that when we have a negative underneath our radical, this causes us to have an imaginary value, or the square root of negative 1, which is equal to I. Because this factor right here literally means the square root of negative 1 times the square root of 68. And remember, the square root of negative 1 is equal to I, so this is like I, square root of 68. But we have to break that square root of 68 down. So some of you might have your square root charts with you. Some of you guys may not have that square root chart with you. So we're going to calculate that and see if I can help you guys out with that. So on your square root chart, you would notice that 68 falls in between two perfect squares. It falls in between the perfect square of 64, which is equal to 8. And it falls also in between the square root of 81, which is equal to 9. So now we're going to ask ourselves a couple questions. All right, so that means we've got to check and see, will 8 divide into 68 evenly? It will not. So we're going to move down to the next value, like getting smaller. The next prime number we can see is 7. Will 7 go into 68 evenly? No. We're moving down. Our next prime number is not 6, because that's a composite. We try 5. Is 68 divisible by 5? No. We can't use 4 because that's a perfect square and it's composite. So then we try 3. We're like, will 68 go into 3? Nope, 68 is not divisible by 3. So then we're going to try 2. That's the smallest prime number. and 68 is divisible by 2. So we're going to take our 68 and we're going to divide it by 2. 68 divided by 2 is 34. So now we know that this is the same thing as 2 times 34. So now we're going to take our 34 and break it down. So we can look at our square root column again. So 34, I'm going to bring another color over here for you guys, 34. So 34 falls in between two perfect squares. It falls in between 25, which the square root of 25 is 5. And it also falls in between 36, which the square root of 36 is 6. So we'll start with 5, and we know 34 is not divisible by 5. We'll go to the next prime number, which is 3, and 34 is not divisible by 3. So we go to the next prime number, which is 2. And we're going to take our 34, and we're going to divide it by 2. So now we'll get that 34 divided by 2. So now this is the same as 2 times 17. So now to find out what will go on the outside, we notice that we have one pair of 2's. So here we go down here. We're going to have our x is equal to 4 plus or minus. We got our I. We'll put it with it. So we got one pair of 2's. So that represents the one pair of 2's. Oh, I'm not on your screen anymore. Hang on. Let me see if I can get in the screen. Okay, there we go. Trying to get this in there. All right, can you guys see that better? Okay, I think that's better. So then we've got our I for our imaginary value. And then we square root of our leftover piece, which is 17. And we can check to make sure we have this answer correct by taking the number we pulled on the outside and multiplying it by itself or squaring it. 2 times 2 is 4, and 4 times 17 is 68. So we know we factored this correctly. So then we'll put this all over 6. So now we have to reduce our fraction, if we can, by looking at the three coefficients, 4, 2, and 6. And we say, are 4, 2, and 6 all divisible by the same number? Or do they have a GCF? Which they do, which is 2. So we're going to take that 4 and we're going to divide it by 2, and we'll get 2. And we'll take this 2 and divide it by 2, and we'll get 1I, or just I, square root of 17. And then we'll take this 6 and divide it by 2, and we'll get 3. So now we have our final answers. X is equal to 0 from the very front at the top, and then it's equal to 2 plus or minus the square root of I square root of 17 all over 3. Okay, so our factoring technique number 2, so method 2, is quadratic trinomials. Now these are pretty quick and easy. They're not as hard as a GCF. If your brain was fried from the GCF, you're going to love the quadratic trinomials. They're nowhere near as hard. So on these, you can solve these quadratic trinomials by using the X-box method. This is the X-box method. So we're going to use the X-box method on these. All right, so we're going to use the example they provide for us, which is 6x squared plus 11x minus 10. All right, so first thing we're going to do is go ahead and create that X box. Bam. Beautiful. All right, so remember from our previous notes, so we're going to use the top as our A times C. So we first got to identify our A, B, C, quadratics, and me. So who is my A, my B, and my C value? All right, Keon, who is my A value? That is right, it is 6. There it is, A value. Who is my B value, Keon? That's right, it's 11. Right there's my B value. And who is my C value, Keon? That's right, -10. Great job using that negative sign, realizing the sign to the left determines whether it's positive or negative. All right, so here we go. We're going to multiply A times C. So what is 6 times -10? That's right, Coco. It's -60. And our B value? That's right, Geo. It's 11. So now we're looking for factors of -60. So when I multiply numbers to get 60, I need them to add to be a positive 11. So let's take a moment and think about that. Okay, so when our A times C value is negative, and that means one of our values, our factors on this side or this side, one has to be positive and the other has to be negative. Because a negative times a positive is negative, but we can add a positive and a negative together and still get a positive value. So let's look at our factors of 60. We got 1. Is 1 plus 60? 1 plus -60? Because we know 1 has to be negative. They both can't be positive, so there's no sense in writing that down. So 1 plus -60, would that make positive 11? Nope. What about -1 plus 60? Would that make positive 11? Nope. So now we're going to try dividing 60 by 2. So 60 divided by 2 is 30. Is 2 plus -30 equal to 11? No. What about -2 plus 30? Is that equal to 11? No. All right, we're going to ask ourselves, is 60 divisible by 3? It is. So we're going to see, is 3 plus -20 equal to 11? No. What about -3 plus 20? Would that be equal to 11? No. Then we're going to ask ourselves, is 60 divisible by 4? And it is. So we're going to ask ourselves, is 4 plus -15 equal to 11? Close, -11. So what if we did -4 plus 15? Ah, that's the answer we're looking for. This is the humdinger right there. All right, so now our factors are -4 and 15. So we're going to write those down, -4 and 15. Because -4 times 15 is -60. And -4 plus 15 is equal to a positive 11. Fantastic. But we're not done. We have to put each of these values over the A value. So what is our A value? That is right, Jeremiah Burton. Our A value is 6. So we're going to put 6 under each of these. So now, Raina Smith, we want to reduce these. What is -4 and positive 6 both divisible by? That's right, Raina. They're both divisible by 2. So if I do -4 divided by 2, I get -2. And Raina, if you divide 6 by 2, what do you get? That's right, 3. And we cannot reduce this any lower, so we put our x down here, 3x. Now look at 15 and 6. Lily, is 15 and 6 divisible by the same number? That's right, Lily. What are they both divisible by? Yes, 3. All right, Lily, what's 15 divided by 3? That is 5, correct. And what is 6 divided by 3, Lily? That's right, 2. And we cannot reduce 5 over 2 any lower, so we put our x down here. This now creates our factors. So this factor, starting with the bottom, is 3x minus 2 on the top. This factor, starting with the bottom, is 2x, and it's plus 5 because we have a positive 5. And it's minus 2 because we have a negative 2. So now our factors are 3x minus 2 times 2x plus 5. These are the two factors, and we set this equal to 0. So now to find, I'll bring this up a little bit, and then you can, hold on, there we go. It'll make your eyes go funny there, get a little seasick on us. All right, so now we're going to take each of our individual factors. We're going to set them equal to 0 and solve for x. So we're going to take this 3x minus 2. We're going to equal it to 0. And we're going to take this 2x plus 5, and we're going to equal it to 0 as well. All right, so we want to get this 3x by itself. How do I move that minus 2? That's right, Jaron. I add 2. So 3x minus 2 means I got to add 2. If I add 2 on the left, I have to add 2 here on the right. So what is negative 2 plus 2? That's right, Jaron. They cross cancel each other out, leaving me with 3x. And 0 plus 2 is 2. Now I need to get the x by itself. This operation is indicating what? That is right, Christian, multiplication. So the opposite of multiplying is what, Christian? That's right, dividing. And remember, fraction bars indicate division. So we divide by the coefficient of 3. 3 divided by 3 is 1, and 3 divided by 3 is 1. So 1 times x is 1x, and over 1 is just x. And we cannot reduce 2/3. We do not change it to a decimal. If we cannot reduce our fraction any lower, we just leave it as a fraction, either whether it's proper or improper. So 2/3. Now we're going to move to our second one. Tell me, what will we do first now, Mackenzie? That's right, subtract 5. So we got 2x plus 5 minus 5. And if we subtract 5 on the left side, we must subtract 5 on the right side. All right, Mackenzie, what happens to that plus 5 minus 5? That's right, they cross cancel each other out, leaving me with just 2x. And what does 0 take away 5, Mackenzie? That's right, negative 5. All right, so now, Alex, what would we do? That is correct. We would divide by 2. Again, remember the fraction bar indicates division. So the 2 divided by 2 is 1, and 2 divided by 2 is 1. 1 times x is 1x. Divided by 1 is just x. And we cannot reduce 5 over 2. This is an improper fraction. We do not change it to a decimal. We leave it as an improper fraction if we cannot reduce it. So it just stays negative 5 over 2. So our final answer would be x is equal to 2/3 and negative 5 over 2. Fantastic. All right, so for our next method that we're going to go ahead and do is the perfect square trinomials. So method 3. Perfect square trinomials. Now we've already learned this year. Remember, we called this the PST. Perfect square trinomials are our PSTs. So there are formulas for this, and we want to write the two formulas down so that you understand what this means. So if we have any value, and we'll say A, added to any value, we'll say B, and we square it, now we have a perfect square trinomial with the sum of two values. So I'm saying some value plus some value, and that value being squared. To get that result, we take the first value, which is A, we see here, and we square it, A squared. To get the middle term, we multiply the two values together. We're going to multiply A times B, and then times 2, because we would have two identical pieces in the middle. So it's 2 times the A value times the B value. So 2 times the A value times the B value. Then to find the last term, we take the B value and we square it. We multiply it by itself. So let's do an example with just this one first, and then we'll do the with the subtraction. So we're going to do x plus 5 squared. So here we go. Let's try this. We're going to take the first term, the value in our A spot happens to be x. This is the value in the A spot right there, corresponds, the A spot, and this can correspond to the B value. The A value, then the B value. All right, so we're going to take this x value, x, and we're going to square it, plus 2 times the A value, which is x, times the B value, which is 5, plus we're going to take the B value, which is 5, and we're going to square it. So now we can simplify. X squared is just x squared. 2 times x is 2x, times 5 makes 10x. And then 5 squared is 5 times 5, which is 25. That is our perfect square trinomial. All right. So now if we were to go backwards with this, how do we determine if something like this is indeed a PST? So to determine that, we take the first term and we find the square root of it. So the square root of x squared is x. And notice that is the same as our a value, our first term, x. We take the square root of our last term, which is 25. The square root of 25 is 5. And notice that's the same as our b value, which is 5. But to be 100% confident that we have this, we have to verify that is 2 times x times 5 equal to 10x. And indeed, it is equal to 10x. And as long as our back term is positive, now we know we have the correct answer. So now this would be a PST. So this would factor back to x plus 5 squared. All right, so now let's try the second one. We're going to do a, so any value minus any value squared. The rules will be the same. I'm going to move up a little bit. All right, now I'll give you eyes of time. We're going to square the first term, a squared. Then because we have a minus sign in between, we're going to do minus 2 times the a value times the b value plus the b value squared. All right, so now we're going to pick, again, just another one to try. We're going to use the different values. We'll do x minus 5. We'll just change this, keep the same numbers, but just put minus. All right, so we're going to take our a value, which is x, and our b value, which is negative 5. So our a value, which is x, and we'll square it, minus 2 times our a value, which is x, times our b value, which is 5, plus our b value, which is 5, and being squared. All right, so now we've got x squared, negative 2 times x is negative 2x, times 5 makes negative 10x, and 5 times 5 makes 25. So here is our PST that we have. So now this is a PST. So again, to double check it, if you were given something like this, so to verify that this would be indeed a PST, again, just like the first one, we got to find the square root of x squared, which is x, which matches to our a value, and then we'll have to find the square root of 25, which is 5, and it matches to our b value of 5, and then we have to verify that negative 2 times x times 5 is equal to our negative 10x, and it does equal our negative 10x. So indeed, this would be a PST, and if it was factored out, it'd go back to x minus 5 squared. All right. Okay, so method number 4 is one, again, that you guys have already learned, and it's the difference of 2 squares. And remember, we've learned this as our dots, the dots method. Difference of 2 squares. This is our dots. So the difference of 2 squares, this means we got any value that is being squared minus any value being squared. A squared minus b squared. That's the difference of 2 squares. Sometimes it's written in parentheses. Other times, it is just written a squared minus b squared. But either one will factor the exact same way. So to find the difference of 2 squares, it creates 2 sets of parentheses. We take the square root of the first term, which is a, so square root of a squared is a, and we give that to each set of parentheses. Then we'll take the square root of the last term, which is b squared, and the square root of b squared is just b. And then one of your values will be positive, and the other will be negative. This holds true because a times a makes a squared. If you multiplied, so let's do this together. A times a is a squared. If we multiplied a times negative b, we'd get negative ab. And if we multiply b times a, we get a positive ab because I'm listing them alphabetically. And then b times negative b is negative b squared. Notice here in the middle that our negative ab plus a positive ab would cross cancel each other out, leaving you with just a squared minus b squared. So that's the reason why when we factor this out, a squared minus b squared, or the difference of two squares, is a plus b and a minus b. So now we're going to do an example with values. So let's do one like, let's do a couple actually. I'm going to start an easy one, then we'll move up. Let's do x squared minus 16. So now we've got x squared minus 16. So we ask ourselves, x squared is a perfect square? Yes. 16 is a perfect square? Yes. And this is a subtraction sign. So this would factor into two sets of parentheses. So the square root of x squared is x. The square root of 16 is 4. One would get a positive and the other would get a negative. But sometimes you will have values in front of your x squared. So let's say, for instance, we get 25x squared minus 9y squared. So now we're going to throw in some other values. We're still do the same concept. So we're going to still have our two sets of parentheses. That's going to change. For dots, we take the square root of the a value. This whole thing is your a value right here. So we got to find the square root of 25, which is 5, and the square root of x squared, which is x. So that we'll each get a 5x. This whole entire unit back here is your b value. So you have to find the square root of 9, which is 3, and the square root of y squared, which is y. So they'll each get a 3y. And then the signs are different. One is positive and the other is negative. Sometimes, if they're written in a weird way, like the example provided in your book, which says 4x squared minus 15, and they say, I want you to use the difference of two squares. You could. Even though 15 is not a perfect square, we can show that it is not by doing the following method. So we're going to make our two sets of parentheses, just like we've been talking about. So this whole entire first part, that is our a value. So the square root of 4 is 2, and the square root of x squared is x, so they'll each get a 2x. And this whole entire back part is your b value. Well, the square root of 15 is not a perfect square, so only way we can write it is square root of 15. Because we can't find the square root of 15. And one gets a positive and the other gets a negative. Then from here, you could find or set each of these equal to 0, each of your factors equal to 0, and solve for x. All right, we're going to pause and move to the next one. All right, method number 5. Okay, method number 5 is factoring by grouping. To do factoring by grouping, you must have 4 terms. This is what we need to do factoring by grouping. And so I'm going to give you how they show it in your book with examples with variables, and then we'll show it with actual values. So they're saying here we're going to have, say, ax plus ay plus bx plus by. So with factoring by grouping, the first thing they want you to do is to group together the first two factors. So you put the first two factors in parentheses, just like this. And notice that I included this sign in here because sometimes that sign is negative, and that's going to be very important, and we'll show you that here. I want to make sure you see that because the book does not give you all those examples. So once we do this, we want to find the GCF of this set of parentheses. And then we want to find the GCF of this set of parentheses. So notice that in this first set, they both contain the variable a. So our greatest common factor for this first set would be a. Notice in the second set, they both contain a b, and both are positive b's. So then our GCF would be a positive b. So we're going to factor out that. So I factor out an a from the first set. I will divide ax divided by a, which is just x.
Weird.
No, all this basically is doing is sometimes some of their computers act wonky donk. I think like one or two of my whole kids had to do that because the internet acts wonky. Like if it's logging in or trying to get loaded up, it messes up, it glitches. Well, then they have to have your permission to get back in again, and that's the only way.
So, but if it says access needed, that means they can't get it in, right?
Not necessarily.
Okay, all right.
Yeah.
I'm getting a bunch of texts now.
Yeah. They'll message you if they can't get in.
Okay, cool. Thanks. Bye.
All right, here we go for our final method. Method number 6. All right, so our final method that we're going to learn today is method 6. It's called the sum or difference of cubes. All right, just like the other ones that we had the PST for perfect square trinomial. We had the dots for difference of two squares. So I give two little nicknames or acronyms for the sum of cubes and the difference of cubes. Sum of cubes is SOC, so socks. So the sock. And the difference of cubes is doc. So we got sock and doc. Sum of cubes, difference of cubes. So we're going to first start off by the sum of cubes. Sum of cubes, which means we're going to take some value and raise it to the third power. That makes it a perfect cube. Sum means we're going to add it to another value that is raised to the third power. So it's a perfect cube. When we factor down a sum of cubes or a difference of cubes, it's going to factor into a binomial followed by a trinomial. So the method is we're going to show you how to do these and follow the steps. So the first step they want you to do is take the cube root of a cubed. That means what number times itself 3 times gives us the beginning value. So the cube root of a cubed is just a. And they want you to find the cube root of that b value, b cubed, which is just b. Now from once we do here, we use this guy to help us to find what's going to go here. So this value now in the middle will be our a squared value. Then we'll multiply a times b together. Notice I haven't put any signs in yet. I'll explain that in a second. And then we'll square the b value and get b squared. Anytime that it is the sum of cubes, it will always be a minus value here and a plus value here. That rule will never change. So all you have to use is these two numbers to give you the 3 values, and then you'll put your minus sign and then your plus sign. So let's do a sum of cubes. So we're going to do x cubed plus 8. All right, so first step is they want us to find the cube root of x cubed, plus they want us to find the cube root of 8. That's what they're asking us for. And the cube root of x cubed is just x. And the cube root of 8 is 2 because 2 times 2 is 4, and 4 times 2 is 8. Because 8 is the same thing as 2 times 2 times 2. See how it takes 3 2's to make it 8? So the cube root of 8 is 2. So now we no longer need any of this. We're just going to use him. So we're going to take our a value, which is x, and we're going to square it. We're going to take our a value, which is x, multiply it by our b value, which is 2. And then we're going to take our b value, which is 2, and we're going to square it. And then we're just going to insert our signs, minus, then plus. All right, so I'm going to bring down my x plus 2. X squared is just x squared. Negative x times 2 is negative 2x. And then 2 times 2 is 4. So now I have done the sum of cubes. And here you would finish out like we did on the front. You would set this equal to 0. You would try to X box if you could. If you can, that's fantastic. If you cannot, then you have to use the quadratic formula to find those zeros. All right. So now we're going to move on to the next one, the difference of cubes. So this, I'll make an example for you here. This is our SOC, S-O-C. All right. So we're going to do a cubed minus b cubed. It's going to start out just the same way. You got to find the cube root of each, so it gives us a plus b. We're going to follow the same exact pattern. We're going to square the first term. We're going to multiply the two together, and then we're going to square that last term. Now the only difference in docs is that both signs will be positive. Oh, I'm sorry, this guy's right here should be a minus. My bad, guys. It should be a minus b. Go ahead and fix that in your notes. I am so sorry. All right, so now let's do an example. Let's do x cubed minus 27. All right, so what they're asking us to first off do is find the cube root of x cubed minus the cube root of 27. That's what they're first asking you to do. So bring this guy up. You still can see everything. So now the cube root of x cubed is just x. And the cube root of 27 is 3. And that is because 3 times 3 times 3 is 27. And notice that we have 3 threes, so 3 threes. That's why we have a 3. Now we're going to use this guy to finish out. We're going to take our a value, which is x, and square it. We're going to take our a value times our b value, and then we're going to take our b value and we're going to square it. And then we'll put in our sign, so it'll just be plus plus. So we'll bring down our x minus 3, and x squared is x squared. 3 times x is just 3x, and 3 times 3 is 9. So again, just like in the previous problem, we would set each factor equal to 0, solve for x on the first factor because that would be simple. The second factor, you're going to either have to use your quadratic equation or your x box method. You'll have to decide which method that you would like to try doing. All right, so that is the end of today's lesson. So you will download homework 54 from the from your RenWeb. So you go to RenWeb, you click on the documents or under the homework section, you'll see documents. If you get stuck or something, give me a holler on Remind, and I'll see if I can help you or walk you through that. I hope you guys had a great day, and I hope you do well. And please, please try these problems and see what you guys come up with. And I also put good examples in there for you as well. Have a great day.